if you want, I can start. I can start sharing my my screen. Cool. So let me move this here. And if correct, you can see my screen right now.
Beautiful. Yeah.
Perfect. Yeah, cool. Thank you so much for the invitation. So I am a Dutch fashion tech designer. I live in Miami area in Florida, and I create yeah, weird stuff using robotics and the body and sensors and all of that stuff. So I'm gonna tell you a little bit, yeah, about my work. This is my name. That's how you can find me. And yeah, most of my work has to do with the body and with electronics on the body. And one of the things that I research is the world, yeah, surrounding the body. So you have the intimate, the personal, the social, and the public space. And these spaces I sense using sensors, using proximity sensors, using ultrasonic rangefinders, and all the sensors that I can find. So this is a theory of proxemics, so the proxemics theory of Edward T. Hall. And in the 60s, he was measuring people's personal space using like a wooden stick, so a very analog way of measuring that. And he was yeah, writing his research down. So I took that research and I used it in a digital way, using sensors. So my sensors are measuring up to 25 feet in front of the design, for example, and it can exactly see yeah, who is in and who's approaching a person into the personal space, social space, or intimate space, and all of that stuff, and also who's standing in the yeah, public space around this design. So how that comes out is, for example, in one of my designs is the spider dress, which I created when I was working at Intel, the semiconductor company in Portland. The spider dress works on ultrasonic rangefinder, so it measures 25 feet in front of it, and it can measure and it can see when people are approaching yeah, the space. So it can see the speed on which a person approaches and also where the person is located, sort of. And dependent on that, it chooses between 12 states. I call it 12 states of behavior. So depending on the interaction with this design, it's reacting to you and it's reacting to your speed and where you're standing in the space in front of it. And what it does is it's embedded with servo motors, 5-volt servo motors in these mechanic legs, and it's really, yeah, attacking. It's really coming after you, sort of. So this is how that looks like. So the design is 3D printed, and yeah, all the whole shoulder parts, it's all articulated. So the piece itself is 3D printed from PA12 in an SLS technique, so it's selective laser sintering and then hand painted at that time, sprayed and hand painted. What you can see here in the back is all the electronics. Sometimes I like to show off the wires because I think it's aesthetically pleasing. Other times I like to hide it. In the case of the spider dress, I wanted to create a really educative design that people can exactly see where all the servo motors are going, where they're going in, where the sensors are. Because one of the things that when I created this dress was for Intel, and they just brought out the Intel Edison and they wanted to focus it to the makers, you know, and a lot of makers are a young audience. So with this dress, I really wanted to show exactly like sort of the outside circuitry where everything was going. So it's a very aesthetically pleasing design with all the wires for me, you know. So here you can see some of that. This was at the showcase at CES in 2015, I think. And yeah, the design works on ultrasonic rangefinders, and it also measures the respiration. So whenever, yeah, you breathe in and breathe out, the system goes into quiet mode, because otherwise it would always be attacking, even when she has like a friend in front of her. So that would not be fair of that system. So another of the dresses is the smoke dress. So it's based on, it's also another 3D printed dress. It's TPU, thermoplastic polyurethane, and also PA12, also SLS. This was the biggest yeah, parts that at that moment, that was 2010, 2011, we could print on a selective laser sintering machine, which was kind of interesting because they just released this material called TPU, which is not, yeah, which is pretty known now, but they were in experimental state back then, yeah, recreating the machines that they had in order to fit this rubbery material almost in there that you can print. The smoke dress has another animals, the octopus. So the octopus is pushing out ink and almost dives away. So this dress has sensors, and it measures how many people are in the direct environment of the dress, and then it starts to smoke. And that was an project for the company Volkswagen, and they asked me to do a big fashion show for their 2012 release. So that was one of the first times that a whole week the designs were there on the models for I think 6 times a day. So there was a lot of shows. Everything was controlled over the DMX system, which is an sort of the way you control lights, because that there were a lot of lights in that space. So that was kind of the first time that I did things over in DMX controller in 2012. So that was interesting. Another project is the drinkable dress, which I created for Cirque du Soleil, which is one of my collaborators. So it's a dress based on an peristaltic pump, and you push a button and the drink comes out. And they had a restaurant in Ibiza called Heart Ibiza, and they asked me to create some food experience. And I wanted to make a dress that shoots bubblegum and one that was serving cocktails. So they were in different colors, and here you can see the peristaltic pump from Party Robotics that I embedded in the back piece, and here you can see them walking around. It was like different colors, so it was just like this really, kind of fun project for them. So with my designs, with my projects, I'm looking at different ways that answers the question: if and when we put technology on the body, what does it do other than just blinking and bleeping? What is the meaning? What is the interaction? And how can it do something in a social, playful, like this defensive, behavioral, and expressive and kind of emotive notion almost, you know? So fashion really becoming an interface. So where I come from is fashion design. I started with fashion design when I was 14 years old. I thought it was cool because fashion was what I noticed was really expressing people. The way people could tell something about themselves by the things that they wore. I thought that was interesting. So I started to study fashion design. A few years in, I started to notice that it's analog. It's very analog. What I wear now, I will wear the whole day. It's not changing. It's not changing phase. So that was less interesting for me. And I realized that. So I got interested in robotics when I was 17 years old, and for me the robotics were the brain and the heartbeat, you know, that I want my garments and my fabrics to have. So that is the time that I started with robotics, started with electronics and sensors and computers and all of that stuff. So that is what I have been weaving into there. So it's researching being a social interface, a playful interface, and an emotional interface. So one of the things, a few of the things that I will share is prototyping, R&D, open source collaborations, and body signals, which is the part which also has the EEG and the BCIs in there. So one of the things with prototyping is always what I try to explain is you have your material or your microcontroller or whatever you have. This is a PDLC foil that was in 2020. It was fairly new. People did not know what to do with it. It was flexible. It was damageable. It was very fragile. So a Russian company was asking what they could do with it, and they gave it to like some research labs in the Netherlands. So one of the things that I do when I find a new material is like trying to see what it can do, but also what it cannot do. So in material research, especially what it cannot do is important. So you want to like look at the boundaries, what the material can do, for example, you know. So that is mostly how I approach design and these design challenges, seeing the possibilities, but also the problems in that. So that is a material that didn't have too much like flexibility in this case, and we needed to work with ways to create more aesthetically sort of using the surroundings of the design of the body almost. So that is Intimacy 2.0, which is a little bit more material based, and in where you can see that the wires are more covered than shown, for example, other than the spider dress, which I explained before. This was a project for an architectural studio in the Netherlands. It's called Studio Roostergaarde, and in where we were looking at material and the body. So that's became this project. R&D, so research and design. The smoke dress that you just saw came from several versions. I think the smoke dress had 9 versions. In where I started with sort of a drip system and dry ice, which had sort of more chemical reaction, which is not always handy because you cannot really control it, to like really big systems that I created on the body, which looked nice from the front but not necessarily from the back, into systems that I'm using silicone fluid and a hot nozzle system, which is based on the back. But this is one of the earlier versions of the smoke dress, which was not 3D printed. So my designs start mostly out as sort of prototypes or mock-ups, and then they grow with me. So there was an earlier version of the smoke dress, and also the spider dress. The version that you see, the 3D printed one, was a baby before. And actually, the spider dress is based on a game called Limbo. So there's a game that came out in 2010, 2011, called Limbo, and it's about this boy walking around in an almost shadow world, and then there's a relationship with a spider that he encounters. And that's actually where the notion of the spider dress comes from this game. It's inspired by that sort of push and pull reaction between this boy and the spider in the game. So one of the first things that I always do is like creating a mock-up, which you can see here with like little strings attached, to just see how the volume goes on a certain part of the body. If it would do, if I would fully engineer it and work on that, what I want it to do sort of. And from there on, I start to work things out into the designs and work on the robotics and the engineering. So here are some of the laser cut version in which I was using a lot of screws. I think like over 200. So one of the things with this dress with Intel was like to work on a 3D model, work on 3D printing. So it would not have the allowance for that sort of that laser cut aesthetic and all those screws. And so one of the things that is important for me is open source, coming from like the open source community. This was a project for Lego, so working on the notion of like things that you can would be able to open source in a later stadia.
With you now, these mechatronic wings won't help you take flight, but they will make you look super awesome. They're made out of Lego, and they've got infrared and ultrasonic sensors that are programmed to react to objects that come near them. The sensors work kind of like bats, bouncing high frequencies to detect objects up to 2.5 meters away. I kind of want these things. And the good news is you can make your own. They're the work of FashionTech pioneer Anouk Wipprecht, and she's recently posted a step-by-step guide on how to build them. So just head on over to our Twitter feed and you can have your own mechatronic wing.
So how that looks like, for example, Instructables or Hexter.io or GitHub, where I try to upload things wherever I can, sort of whenever I can. You can find, for example, step-by-step how you make these wings or how you do other things. And one of the EEG projects is also on this website. And then the other thing is, collaborations with brands, also collaborations with fellow artists, like here, Victoria Modesta, in where, she has some below-the-knee amputee, and I'm creating legs with her and for her. So one of the things is, for example, this smoke leg based on the smoke dress. She steps in it, and the leg starts to smoke. So working with prosthetics is kind of cool because her missing limb allows for me to put a lot of electronics in there and a lot of effects and all of that stuff. So that's kind of a cool thing. So this product called Sonifica, so it has an accelerometer, so she moves her leg, she can make sounds, and there's also a band playing 3D printed instruments by Monad Studio, Eric Goldenberg, and we created this bust for her that she can play. So you can find that online. It's called the New Bionic. It was in collaboration with Autodesk. And then also a recent collaboration was with Rolls-Royce, creating a little Tesla coil in the leg of Victoria. This is her leg light, a light leg. And that was for a campaign for Rolls-Royce for a new car. And I'm gonna show you the leg first. So you can see the black leg has an Tesla coil and a sort of an electricity effect going on there. So how that looks like, looks sleek, but then when you're building it, this is how it looks like. So this is like the little coil. So here on the left side, you can see the sort of the inner works. You can see the Tesla coil, and then you can see here the Tesla coil in the shoe. You can see the circuit board in the shoe and the Tesla coil in the back. So that's basically, I have a better one. You can see a little bit, how that works. So it's often about, putting a lot of stuff in a small space, especially if you're talking about a leg and a feet almost. So that was that's kind of a little bit how I work and how I work together with like collaborators. So another brand that I worked with was Audi, in where they asked me to create a project based on their car. They created a new car, the A4, and they asked me to create a collection based on that. So I wanted to manufacture the 3D printed dresses like they manufacture the cars, like they design the cars using 3D printers, using car lock, car paint from the Audi garage, and also taking out the car sensors and the car headlights. So they are all involved into sort of the design process and the final designs of this this collection. And you can look it up, but these are some of the sort of the 3D things behind that, and then how we were using the power walk. Everything is set up, and then the models were like set in the final sort of the final showcase. You can also find that online. When I work with brands, it's really important that you work on what they have as their what I call DNA, that it mixes well with my identity, because otherwise you create something that either they're not happy with or you're not happy with. So it's always nice to create a good balance with that. So I always say, mix your identity with their DNA in a good manner, sort of. And then it takes me to the topic of body signals, and what this lecture is about is BCIs and EEG. So I work a lot with looking also not only the surroundings, taking that in consideration, but also the body itself. So the spider dress has respiration, measuring the lung volume in order to make that into an action and input. I use brain, so EEG, I use EMG, muscle contraction, galvanic skin response, accelerometers for the place and space and movement. The heart rate and the heart volume is interesting. I like lung volume because the data from lung volume is a little bit more organic almost, it's very rational. The heart rate is very rational, but it's kind of cool to to connect and to couple multiple body signals, body sensors together, what I always think. So one of the projects that is very interlinked with that is 2014, the Synapse dress that I created for Intel when I was working at Intel in Portland, based on the Intel Edison, which was their sort of module, their sort of microcontroller platform. The dress is called Synapse, and what it did was it had an headset. It was like an hacked NeuroSky. It was doing EEG or more EMG in a way, because more the frontal part of the head, and I could not really measure focus with that or anything like that. But what I try to do is like get any signal in from her head region, a little camera in there. There were lights embedded, so it could basically, see what was happening in her surroundings. So my former research and also what was happening in her body. So, and the intention was to measure her like stress levels as she was walking over the show floor. That was for the Intel developer conference. So these lights would go on when, sort of the attention was there from her. And if she goes in the meditative state, you could also like see that from her data. So one of the headsets that I created was this one that had also like a light on there. It was very organic, very artistic almost. And that was, fitting well to the design. So in the backstage, what we could see while she was walking around, we could see by the use of the camera what was happening in front of her. We could see who was around her using the proximity sensors, and we could see how the body was reacting. And this, of course, not the data of that, but we could see how the body was reacting based on her heartbeat, respiration, and also the head region, EMG, and say EEG. So there was kind of an interesting reflection on more an internal design, whether the spider dress is very external and Synapse was really internal to research this. So I got really interested in brain EEG stuff from that point on. That was like 2014. And when I got asked for Ars Electronica in 2016, I said I want to recreate another project based on EEG, and where Synapse was a camera embedded in the dress, and we were taking data from her body. That's not fair because it can just be worn by a model sort of. And what I wanted to do was creating a device instead, and especially do also like a research, sort of a research behind that. So my focus was on children with ADHD, kids that just happen to have more triggers around them that they react to sort of. And of course we can see that in like EEG data, which I thought was interesting. So the idea was to create a headset with a camera embedded that would go on when the focus was being hit, sort of, when we can see that in the brain signals in the data going up. And this camera would record anything and everything that was happening around them. And it's kind of cool to go with these children then back in the data in what triggered their attention. You know, that was my case study almost. So I started to work on this notion, and this is one of the prototypes that it became. Started to work on the notion of first embedding a camera in the headset, working what we actually can see with that, you know, what is the vision? Is it the camera linked? What should the position be? So this was one of the case studies in where I was working with this girl in the Netherlands to see what we could actually see by using different kinds of cameras within this headset. So you can see the prop kind of part still on the back. So the first step is always like, making something, drafting something up and testing with it. So that was almost this part. And you can see that this one doesn't have the sensors in the back region yet, which I will explain. So it's purely on the where the camera is placed and what you can see. So from that step, that worked itself out. It was not too heavy. The 3D print was light. It formed well, conformed nice on her skull. We had it now as large kind of thing for kids. And I'm using PA12 and PA11. I think I did a trial with that using different thicknesses of the 3D pin, so it could like collapse well around the head region, because that's always a problem with BCIs, that people have different shapes of heads. With kids, it's a little bit easier because it's less of a division there, sort of. So one of the things that I got in contact with was a company called GTech in Linz, and Christoph Gucker. So he was my advisor on this project. And what I wanted to do is, instead of, I guess I have a picture here. No, I don't have. Instead of like having a whole head with, sorry for that, having a whole head with like sensors, like 64 sensors on a kid's head in a white room with a doctor, you know, and a setting that kids are normally being measured. That was something that I didn't want to to have to deal with, because then for me, my feeling was the data that I get from the children is not pure. It's not in their playful state. It's more in a monitored state, in where they are in a white room with a doctor. They're not going to be their playful selves almost, you know. So I wanted to work around that by limiting amount of sensors on the head, in order to still get what I want to, still to measure the focus and all of that stuff. So Christoph Gucker went through with me a few things and possibilities. So the one that we came out in that conversation was the P300, to research the P3 wave of the ERP. which could close out most of that, and also created this nice mohawk situation on the head, in where I could use the back of the head to place these sensors on. So that works out really well, which you can see here. So here you can see then the new headset with the placement of the sensors for the ERP4P P3 wave. So that became this this headset, which was kind of cool. The use of the unicorn horn was again to stimulate this notion of play, instead of an right room with a doctor, to have a unicorn horn, which is magical, of course, you know, and kind of cute. And the children reacted really good on that. I did like a design study on how different kids reacted to different kind of sizes and styles of unicorn horn, and they really liked this one, the really big one, sort of, you know. So that was kind of cool. And then I also spray painted them in different colors: white, black, pink, gold, silver, to see which one they would take, you know. So that was kind of a really playful kind of thing of creating a very playful BCI, and that could actually get them much more and much faster into a playful state, you know. So that is something that the aesthetic and the design really works with that. So that was kind of a funny research on that. So this was the really messy prototype, one of the demo versions, into the one that you saw, like where everything was built in. It always looks really terrible when you're testing things and then have to build it in again, sort of. And yeah, then we actually went ahead with GTech. They started to create this this device based on that, with inspiration of 18 Unicorn, and they were a little bit on the notion of like, yeah, having something that is medical grade but available, instead of a system being 20,000, being €1,000, and still have the medical notion coming from the medical side instead of the commercial side. So actually, yeah, working medically. So that became the Unicorn, the brain interface, unicornbi.com. And the cool thing about this is like it's $900, so it's already cheaper than medical situation. But yeah, for people that still want to get into the BCI fields that might not have that money, they were also organizing based on 18 Unicorn, these hackathons. So they were taking place in a lot of cities all over the world. Also now with COVID online, some of them GTech is doing. And that was, yeah, a designer hackathon inspired by 18 Unicorn in 2017. That started 2016. We already did like a hackathon with it at Ars Electronica, and that's kind of a really cool way of yeah, saying, okay, you can buy this device, but even for the people that cannot afford it, or you know, or students, or people that really want to get into the BCI field and have to deal with like a cheap commercial device that might not work because they are maybe more EMG, muscle contraction, than EEG, which is brain signals. This was a really good way to work around that, sort of, you know, instead of buying a medical system of 20K. So that was yeah, a really fun project, which then became a little bit also in the maker realm, took it from medical EEG to research to yeah, actually being a product, and also in the maker scene. So that trickled down in a really nice way. And we teamed up again with GTech and also the Johannes Kepler University in Linz, in where Christoph Kuker asked me on a project that they were doing based on a 1024 brain-computer interface. So it has 1024 channels, in where normally, of course, you work with 64 in hospital situations. That's a little bit more regular. We work with 8 electrodes in 18 Unicorn in order to make it, yeah, the aesthetic, and having that research of like limiting the amount of electrodes while still yeah, researching a certain wave. Now we went the other way of having 1024 channels, which was kind of a cool thing. And the question was like to create a sort of an input-output situation in where you have, yeah, that amount of channels, which is correlating to a piece, and in this case, a dress. So it communicates to 64 actuators. So there's lights involved, and there's also like movement, so little servo motors. So that became the Pangolin Dress and BCI. Our models needed to be having no hair. So we scouted models to have no hair, or having them to shave, like, hey, do you want to shave off your hair? And Dalietta, who you can see here in the picture, and also Maggie at Ars Electronica, they were like, yeah, totally down for it. And it just looks great on them. Dalietta already was bald, and Maggie had like a little bit of hair. She shaved it off for us. So that was really, really cool. So if you want to get into this, like, you do need to shave your hair. So maybe that's setting an interesting trend. And for boys, it's more accessible, of course. But yeah, we needed to find a way to put all those PCBs on the head. So it's 64 PCBs, and every PCB has 16 channels, so 1024 channels by that, and they were all located on the head. So here you can see, I was testing out with some of them. Here you can see the dress. The dress is again PA12, selective laser sintering, and these laser cut plates. I was using Adafruit NeoPixels, and I was exposing them because I actually wanted to cover them, but I like the exposed kind of notion of, again, showing the nerdy, the techie, and the witty, and yeah, showing the NeoPixels, because it gives a little bit more allowance for makers, I think, to better understand just how easy it is to do cool things with electronics. So that became this this dress, which is the Pangolin Skills BCI. I think I have a little bit problems with the movie, so you might want to like look it up online. You can see the workings there. No, it's blank. This video had some hiccup when I presented it like this morning, so I'm sorry for that, but you can find it. It went into the media, and when you're still like busy with a project, you're just like trying to figure out how everything works technically and stressing about that. The media already took it and they made this an address that can read minds, which I was like, at first I was like, and actually it does, because it's reading your mind, but also expressing it, of course, you know. But they really took the angle of like this dress can read minds, which I thought was really funny, because you're just putting something out there and people take it and run with it, and then you get this back. So that got a lot of like reactions to it, and we were like, yeah, of course, yeah, sure. But I think, the really important thing is like the use of the 1024 electrodes or the channels using the 64 PCB sort of, you know. I think that was the real hero there, not necessarily the dress. The dress is just cool because it was doing the data visualization, right? So this was done at Ars Electronica, and I hope that this video will play. Here you can see the putting on all the electrodes. So you can see each PCB has the 16 electrodes on the head. So this is our model Maggie. In this case, it's not wireless. It's a lot of like wires involved in this experimental project. So the next step is making that all wireless. Here you can see the dress. This is the first testing, connecting the system. The cool thing is that we had Maggie for 3 days, so it's like kind of cool, because especially working with EEG and other body signals, even your heart, like whatever body signal, the more you play with it, the more you train with it, the more you can control it. So that's kind of a really cool thing, working with body signals, because even if that's breathing, even if that's your heartbeat, going into like a meditative mode versus like a neutral mode versus a nervous or stressy mode. And of course, you can also trigger that by like loud sounds, bright colors, interactions that you have, sort of. So that's kind of, for me, the really cool thing working with body signals is that, all that data fluctuates so much, and you can interpret that in like really different ways, sort of, you know. So working with Mackie over several days, or with any person using body signals or these interactive dresses that are connected to both the body as the surroundings, is just like a joy to work with. That's a little bit that project I already mentioned before. Open source is important. We haven't open sourced this project because we're still busy with like a lot of things. I hope to open source 18 Unicorn soon, but I'm still busy with a second version in where I'm still working on like adaptability to the head size. So some design problems that I have to solve, also the sensors, and also these sensors are not really easily available, so I'm just trying to figure out still how I can open source 18 Unicorn. Maybe like, I mean, you can almost like, I can think of 3D printing or like other things, but it's still a little bit a design challenge to open source that design. But I do a lot of open sourcing, so you can think of GitHub, Thingiverse, Instructables, Hexer.io, people that are interested in BCI, open BCI community is really cool, and all of that stuff. So there's a lot of like open source initiatives available. So if you look at my Instructables, I try to do as much as I can, like putting these products online. Also Hexo.io, you have like the little kitty ears in which I learn kids to make their own kitty ears, and they light up. And some people made them like sound reactive, and you can see them sometimes. Mature people, I meet them at events or festivals, and they're wearing them. I was like, hey, cool, you made them, you know. So that's kind of the cool thing about this community, you know. Not everything needs to be paid for, you know. What can we do to make things free and educative as well? And I think I'm really pushing for that. I think that's really sort of a really important thing, this open source community, and caring and sharing and just sharing our knowledge and all of that stuff. So that's a little bit what I do. You can find me at Anouk Wipprecht. You can find me on social media, and this is my my email address. So I think I went a little bit fast, Firas. I don't think that I made that.
Yeah, but that was like one hell of a presentation. A lot of projects, and I really enjoyed like the whole timeline of projects and seeing the whole evolution of the work, and then where it started and where it arrived, and then all the technologies that have been implemented since the beginning, and then what you arrived to. So yeah, I mean, really beautiful presentation. I loved it. Although I was familiar with the projects, but still as well. I've been swamped by a lot of questions that I should ask you right away, because they're just a lot. So the first question that came in, I'm just going to read it as it is. Will we see widespread mainstream adoption of highly dynamic tech clothing? So just maybe, will that become mainstream and commercial? Will everybody be wearing fashion tech?
I think like it's just really fun. It's for all the reasons that I just mentioned, sort of. There's a lot of there's a few problems that we still have. One is washability. Like a lot of things is being figured out in regards to like washing electronics, because that's of course the number one enemy of electronics is water. So I think like there's a lot of like interesting initiatives in regards to for example, washing machine manufacturers that are creating washing machines without water. So that's a little bit of push from the industry that needs to come more maintenance, like batteries. You know, you want to make these things like solar or kinetic energy based. And like also like the battery size, it's always like square. We want to have flexible, we want to have round batteries. And also maintaining, because if I would sell a dress and it breaks down, are you witty enough to reprogram it? Are you bringing it to a dressmaker, robotic dressmaker, or are you sending it back? So I think like I work a lot on case studies in where I say, I put a certain technology on the body, like what does it do, and I research. So I almost work as a researcher, or if I work for a company, I beta test a lot of their technologies, their electronics. But I also make for myself, sort of these more artistic, how do you say that? Things that I want to push out myself, like the smoke dress and spider dress and all these ideas. And I have the opportunity to work on those ideas with companies, you know. And I think they all address something different. They do not necessarily address, commercially being sold at this point, because there's a lot of problems with, for example, robotics. You know, they're robust, and other than working with soft robotics, which is a little bit more skin-like, you know, I work with hard robotics, of course, a lot because of accuracy. So a lot of these projects are a little bit more case study based, in where I do research, and that is not to sell like fashion, you know, that is to do research to a certain topic, whether that's a statement that I want to make as an artist, whether that is something that I want to solve as an engineer, or a designer, a design challenge. Whether that is something that I want to research on the body as a researcher, you know. So I think I'm a little bit more focused on that than really like selling necessarily like products, which is another thing which is interesting, because you can create a device and bring that to a broad group for them to work with. And that is where Asian Unicorn and the Unicorn BCI is really interesting, because you are able to create a product which bridges to the medical gap, sort of, you know, and you're able to let other people play with that. So I think that's for me is like, the more of the interest, the device kind of sense, but also that's why I'm interested in the do-it-yourself community, because if you can make it yourself and break it yourself, you can fix it. So I think there's also a lot of like that coming up as people get more witty and all. So sometimes I'm a little bit more supportive of that. I can also base my whole life on making products, but product pipeline is just tedious and hard, and that's a lot of work spent. I could make 10 designs in the time that I also create a product sort of sometimes, and especially like a lot of things need to be solved still, washability, maintenance, and all of that stuff.
Definitely, because I think there's something really, really interesting in balancing both being disruptive on the one hand and really avant-garde in this kind of industry, but at the same time maintaining the playfulness, DIY kind of attitude.
Yeah, it's like I'm fortunate enough to get funded, like sometimes by companies, sometimes by things or universities and all of that stuff. So where I want to play Robin Hood, like be like, okay, that is how I get paid. But in my free time, I want to spend time to either educate or to help out. So I think like putting my things online and people can play with it that way, I can also make products and get my money from that. But that's not necessarily the highest priority that I'm interested in money. I'm interested in community. I'm interested in innovation. I'm interested in engineering and design and solving questions, sort of, So it depends on what your focus and what your aim is, sort of. And what I like to do is I would like to get, of course, like my money from my clients, from my projects and all of that stuff, 1/3. I would like to 1/3 work on my own work, my own ideas, to work those out, like what you can see, the spider dress and the smoke dress are my own ideas that I can do in collaboration with the companies. Sometimes I do work for the companies that you don't really see, for Samsung or Google or something that is not really mine to showcase, So that's more hidden. So that's like that 1/3, 1/3 my own art, and then 1/3 is for me education and charity and helping somebody out. That can be a makerspace, that can be a school, education, and I think that's really important to have this way, because what I say, I come from an open source community, from hackerspaces, Arduino being an open source platform board, the internet, like all of that stuff, and it's important if you use these things to also give back in a way. So I might be less interested in making money off of products, and I'm more interested in more the community feel and what is that going to do for society at large, sort of. So more hybrid ideas in regards to that, I guess.
And that actually resonates a lot with the NeuroTechX community, because actually the two pillars are mainly community and creating knowledge in order to produce innovation. And that's precisely what we're here for. So let's just break it down a little bit. Can you just tell us more about, maybe we can break it into the industry, which I think from your presentation we know a lot about now, but maybe you can tell us more about where is fashion and fashion tech at the moment in academia or in research?
I think like the last 5 years, the cool thing is, I would say like the last 8 to 10 years, technology got really interested in fashion tech. Before, when I was working on these ideas in like 2000 to 2005, 2006, 2007, it was well known. It was like less known. It was always putting you in a box, or you're either fashion or technology, but these things cannot be combined, especially in the beginning of 2000s. Also, it has to do that technology was bigger, so people could not imagine that you have a big computer on your body. Now it's like a really small microchip or like a microcontroller and all, So that changed, I think, the size of technology and electronics and all of that stuff. But also people started to realize at one point, the technology industry, earlier than the fashion industry and the art industry, sort of that I think technology industry always wanted to have a link with fashion, but they could never sell a red dress. It's like, that's cool, but that's a red dress. What does it have to do with our product? Now it's a dress that is embedded with technology in there, So all of a sudden it's like, hey, wow, this is the first time that we can get into the fashion field and the fashion brands, and how can that look like? So I think in 2000s, the first part was the entertainment industry for celebrities. We were doing things for Britney Spears, for Black Eyed Peas, the Super Bowl ideas and all of that stuff. So a lot of triggers from LA in like 2007, 8, 9, 10, 11, 12. And then all of a sudden that triggered the technology industry, like, hey, this is interesting what these people are doing, you know? And I think like 2010, 2012 was the time that technology was like, hey, we can do something with this. And then 2013, 14 became the year of the wearables, sort of, you know, which in the past, the wearables were the dresses and all of that stuff. And then it became the activity trackers somehow. So now we got thrown out of the wearables and because the activity trackers took over being sort of the wearables field. But I think that was really the time that a lot of the companies started to understand, okay, this is something that we can put in garments, you know, and that we can connect to the body and all of these concepts that go beyond activity trackers and sort of the wearables on our wrists, because they're able to listen to our bodies in new ways. An activity tracker can only do a few points of contact and a few data points and a few inputs. If you have body sensors, if you're looking at the brain is here, EMG, the place that you can measure things the best, the heart rate, the lung volume, it all wants to be measured on a different part of the body. And I think that's kind of the interesting thing about like garments and interactive garments. They are on all those places on the body instead of only having a wrist watch or an activity tracker on your wrist, you know. And so really, I think taking the body in there is like just of interest of a lot of people, but then it's also a lot of like problems in regarding to washability, maintaining and battery empowering, sort of, you know, that's everybody's still like, trying to figure out.
Sure. No, it's. I mean, so it seems that practicability is a big part of this. But maybe we can talk a bit about if you think about your dresses as like a new skin for the same being, like for the same human, just having now a new skin that is mainly augmented and has more abilities. So it's adding more capacities or more sensing abilities to the same body, right?
Yeah. Yeah, I think,
No, like just to jump in on a bit on the more technical things, because we've been having a lot of questions on this. Some people want to know more about the 3D printing process, and then which kind of 3D printers allow you to print such kind of dresses.
If you're working at like with TPO, so thermoplastic polyurethane, you can use things on your own, like normal 3D printers. I'm in my home studio and I have a Dremel 3D45 here. I have a BMO laser cutter. It's just for me for at home. If I have an idea, I can just like run there and like start to print it out. If I use other machines, are EOS, Stratasys. I'm using SLS, selective laser sintering. I've been using for like more jewelry piece and all of that stuff, Formlabs, printers, resin, and then going up to like an Object Connect 300 or 500 from Stratasys, which is doing like multi-material, multicolor, for example, which is interesting. Metal 3D printing for things like custom heat sinks. If you want to cool down electronics like LEDs that get really warm, for example, Rebel LEDs or something like that, high power LEDs. It's kind of cool to use 3D printers to make your own custom heat sinks. For other things, it's mostly a little bit too heavy, especially in garments. But sometimes, some metal printing you can also use for like robotics. The dresses that you've seen, we mostly printed in selective laser sintering. So it's a powder printing process, which is kind of cool because there's a possibility to like recycle like some of that powder, other than working with a lot of support material. And you can also have much more intriguing shapes that you barely can like 3D print on a normal 3D printer, because you need to get rid of the support material. So it will not be super smooth. And SLS, selective laser sintering printing, allows for that. And it's also the nylon and PA, whatever you're using, it's really light. So that's kind of the cool thing. Even if you have things that look massive, they can be pretty light, especially if you're building in some kind of cavities or taking space away, or making it really thin and all of that stuff. So I think like from that point, it's really cool. And also the nylon is really allowing for it to be not as breakable. If you use Formlabs and you drop it, a resin printer might break. Whether SLS, you can, that's mostly the first thing that I do. If I have 3D print, I just drop it on the floor, and if it breaks, then then that's not a good design in a way. You know? So for me, I'm always pretty clumsy in regards to just testing it out, like just dropping it, because you're gonna drop your stuff, you know. So better do it early and see if it holds. So and SLS, I mostly have good results with that. So
that's a good threshold.
I know, right? Yeah. Yes, how do you test your stuff? Yeah, you just drop it. But
that's awesome.
It can be as simple as that.
Well, that's pretty awesome. So I have like several questions in different topics still. I'd like to know, what's your take on how that changes space perception in the first place? So having a dress that is connected to your brain, so it's behaving based on this data. And then we saw on the dresses that there's the spatial parameters which are part of the input data that you have. Mm-hmm. And then what would be your take on how these dresses, or how this technology embedded on the body directly changes the spatial perception of the person wearing them?
I think in robotics, you talk about like degree of freedom. So the more degree of freedom a design can have, the more you can do with it, the more you can animate it, the more possibilities it has to create more behaviors in there, right? So if you look at the field like biomimicry, it's all about like the process, how things grow and flow and all of that stuff. If you talk about sort of the not mimicking bio, if you mimic behavior almost, you know, like the spider dress, it's a system based on spider legs, but it has a cat-like behavior, because if you come close to a cat, it's gnarling at you, you know, it might not want to have you close. So it's creating a hybrid of these things. And I think then it becomes really interesting. Like if you have just something that is blinking and bleeping, it's not super impressive. But if you look at the aesthetic, for example, of the spider dress, it's a really sharp V shape and like shoulder parts, so it's very powerful design. It looks very eerie, and when you interact with it, it's also pretty eerie. It's really attacking. It's very dangerous almost, you know, when you look at it and when you interact with it. When you look at the smoke dress, it is very much more organic. It's more pear-shaped, sort of, you know, and it's much more elegant. And when you interact with it, this dress, the interaction is also more more elegant. But in the creation of these things, my background is interaction design. So fashion design, robotics, and then interaction design is what I studied in regards to working with the electronics, coding and electronics, and then what does it do, sort of, you know, that's the big question with interaction design. And I think the more you can allow for more behaviors to be embedded in that design, the more interesting that is, sort of, you know. So in the case of the Pangolin dress, is the BCIs corresponding to states within the dress. So a more hectic state, which is white, and the skills are going everywhere. It's much more hectic in the interaction, in what you see in the animation. So the skills are going and they're flickering white lights, which is the brightest. Neutral is a little bit more more organic. It's blue, it's more pulsing, sort of. And if you go into meditative state, it goes purple, and everything comes down. It's like almost like a flowy feel, and much more like a heartbeat, like corresponding to things that we have in our bodies. So I think being able to create a dress, you first need to see how many points of access you have, and how much almost like degree of freedom you have in the things that you want to animate. Because if it's a stick here, you can only animate that one stick. But if you have several legs and they are intrigued with like multiple pivot points, you can do much more with it, sort of, you know. So I think that's always an important thing to figure it out, because otherwise, if you just say, okay, I put light on the body, that's just a really hard thing even to work with, because what does it mean? Either you need to really interlink all those lights to a feeling, but then you can say red can be danger in some countries and it can be love in Paris, right? So what does that notion of color mean culturally, and not only for yourself or for your culture? So I think sometimes working with light can be really hard. So I love to work with robotics because they have that degree of freedom almost, you know. And what does it do to the body, to answer your, or what does it do, sort of, I think we are now connected to our technologies that are not necessarily like listening to the body. Like my phone doesn't know when I get stressed out, sort of, you know. But if you have things on the body that actually they feel with you, you know, and they're able to to live with you through your day. And I think that's for me really enticing to work on that notion of things that can monitor you and that can help you, or that can interact with you or play with you or disturb you during your day. You know, it's not only about helping you, it might be also about how can it bully you, you know. I think those questions are
I'm really intrigued to think about your work as just like an extension of the body rather than something else, you know what I mean?
Mm-hmm. Extension of technology as extension of the body is like almost like McLuhan. I think he's the one that in as the shuffle, you know, we use that as to I think a lot of these things are more like exoskeleton like and are really heavy on the data input output kind of situation, or such systems, but I think that's why a data points like heartbeats, long volume, it's just one thing, but working with brain signals is kind of cool because it has such a diversity in data in what you can gather. So there are so many possibilities. I can think of like 40 dresses already that I want to do based on different things, different like case studies and design situations that I can work with, using EEG only. You can maybe not doing that with the heartbeat because it's just very rational data. Long volume is already a little bit more round, more organic what you see in data, but brain signals are just wild, you know. You can do so many things with that, so that's kind of cool.
Because I come from an architectural background, and then as an architect, I'm really interested in how can we interact with our built environment using a brain-computer interface. So interacting directly between the building or the space that we are in and the brain or mental state. And then when I see these dresses move, producing smoke for me changes the whole spatial layout as well. So introducing more parameters into the space that we're going to perceive as a person who is generating this as well. So I can pick up a lot of words from here. You mentioned fashion as the interface. You mentioned playful FashionTech as well, which I think that's going to be the next startup. So we have some people asking 2 questions several times. So people are asking, what are you working on next? And then how can people seeking collaborations reach out?
You can reach out to me. I think my screen is still on through social media, Anouk Wipprecht, or info@anoukwipprecht.nl. The projects that I'm working on now is one for a company called Vital Neuro, who comes out with a product based on sort of BCI as well, which is kind of interesting because it's more that sort of product pipeline, and we're also connecting it to some artistic experiences. I cannot tell too much about that, but it's it's a really cool company based out of New York. And another project based on EEG, I can also not really enclose, but it goes a little bit onto the regions of the brain, in where we now look at just the input-output situation. It goes a little bit more in what region we're using because of the allowance of this new multiple channel BCI almost, you know. So that's kind of a cool thing, which working with the regions, it's something that is a little bit more experimental because of the sort of the system setup and latency and all of that stuff. But I think that's a cool next step for Asian Unicorn to Pangolin Dress to this new project. So that's kind of a cool thing coming up. It's always like you cannot talk too much on upcoming projects.
I just paused the question because a lot of people were sending me this question specifically, so I was like, I just need to ask it as well, right?
Yeah.
No, because I think after all this presentation, a lot of concepts were introduced, a lot of technologies, and then one would be wondering, like, what would be the next thing? If that's what's happening now, what's going to be next in general, not only as like the projects you're doing, but like what's next for the fashion industry or for the fashion tech industry? What's next for fashion in academia? What's next for all these things, right?
I think fashion manufacturing. I think what I say, the technology industry has been listening very pretty fast, like 10 years ago. What I mentioned, the fashion industry has been like looking over the shoulder like 5 years ago. I think they need to step in a little bit more, especially from the manufacturing angle, that fashion tech definitely needs more innovations, like the washing machine company that I said, people that are making innovations to solve some of the riddles that we have to go through in order to make things manufacturable. And then also, yeah, I think like especially with like fashion, it's hard because yeah, sort of if I design these things, it is a little bit more like technology, from the technology angle based, because I make things, I update them, I upgrade them, and they live on as next versions almost, you know. And fashion doesn't have that, because fashion is in or out almost, you know, and that's their cycle, and they want to make it as short as possible because they can sell the most. And that is not what we want with fashion tech. We want people to buy less, but maybe a little bit more expensive because it's embedded with technology, but it is listening to your body. It can monitor you and all of that stuff. One of the biggest problems with the fashion industry is cotton and the production, and it's very poisonous, and a lot of people get killed by that every year, you know. So that's a big problem, pollution, and also like a lot of problems around the cotton industry still, and the textile industry, and that's mainly because we want to have a lot of like garments cheap, and a lot of them, and our closets, even mine, like our closets are just too big for what we wear, if you look at it, you know. So if we can go to pieces that, and I can say a leather jacket, I have a leather jacket, I want to have it for 10 years. If I lose it, I cry, you know. And I think if you have more pieces that we could cherish, like we cherished our clothing in the
more
past.
value. Yeah.
But that's our intelligence, you know. You want to wear it like your leather jacket. You don't want to have it to be disposed in a week, you know. If something can listen to your body, it almost becomes an extra person, you know, that you have on your shoulder, or something that really knows you and that monitors you, but also learns from you. What I try to say, if you work with body signals, every time it learns from you, it can help you better. It can play with you. It can whatever you want it to do, you know. So it almost becomes an familiar, or like an entity that you have around you. And I think that's a really pretty thing if we can cherish our garments more, you know. But that's not something that the fashion industry currently is doing, because they want to sell. Technology is a little bit more, normally our devices would be like 5 years. Now you can throw them away after a year. So they go more and more towards that notion because they want to sell more as well. But like, let's rethink if we do this, and how can fashion be part of this. But they're mostly not really interested because of that whole notion. They cannot sell as much as anymore. So, but you do see the last 5 years, there's much more interest. The last 2 years, there's a lot of companies, there's a lot of fashion houses also that reach out to people like me that want to work with this, like the technology industry did like 10 years ago, but don't know how, or like how can this look like? Can we like build a case study together and research that? So you do see more of that, but there's an hesitation from the fashion side much more than from the technology side, I think.
Yeah, so there's something very valuable here, and then really valuable in your work, and which is like your fashion is not only informed by technology, but you're using your design and your art in order to push the limits of tech a bit further, and then make tech think about design questions and then how to solve them as well, and then you implement that back.
Yeah, it's a really weird hybrid. And it kind of comes natural now, but I've been doing this 20 years, you know, so definitely in the beginning, when I was trying to do these ideas, I had no, you know, either the technology was not there, or the budget was not there, or whatever. There was always something. And I've just starting to grow. It's like a combination between like myself or with collaborators working on what is it, the interaction, the technology, like, from coding to architecture to design to product design to art, you know, there's a lot of like hybridism in there. With and you also need to think of different design solutions. What I say, I put in different hats on. I look at some things first, like maybe the designer, how should it look like? Then I put the engineer, know, how should it, what is the mechanic properties that it needs? Then I'm the coder, and then I'm the architect. Or, you know, you need to go through all of these roles in order to create that. And that's kind of a really playful way of designing, which I really like, and the other thing is like you need to, sometimes you're sewing, sometimes you're soldering, sometimes I'm coding, sometimes I'm designing, like 3D printing, laser cutting, whatever, it's a really fun thing to do as well, and that's why I always like to get people involved in it, because if it's a field that's not fun, you don't want to have to do that to another person, right? But this is also, I think, what gives me the joy myself, why I just want to get more people involved in it, because there's a lot of like curiosity, and there's a lot of like cool things that you can do with electronics. It's as simple as that. I make fashion tech designs, other people make robots, other people make products or devices. So
I'm gonna throw in a concept that I don't know if it's there in the fashion industry, but like, what would be your take on cyborg fashion or fashion sci or something like that?
Yeah, I mean, of course, cool. But it's depends on how you define it, sort of. I think like the 90s had a really big like cyborg movement, and it's almost like, what is cyborg and what is us, sort of. I think there's a lot of like people like Neil Harbinson. I don't know if you know him. He
he's in Barcelona.
Yeah, he got born being colorblind, and he basically created his own device to see colors again. And he has this little antenna for the people that don't know him. I think, they call themselves like Cyborg, and they create this really big cyborg movement. For me, it's, I think, always important, especially if you're talking also about brain and BCIs, that I love more the exoskeleton style of things connected to the body, but not connected inside the body. For example, Neuralink and Elon Musk's thing is kind of cool, but you do need to make a hole. Holes in your head. That's not something that he says. It's like, oh, this cool thing. It's like, well, how does that look in? It's a lot of, you need to drill holes in your head in order to make direct connection. Which is great, because the resolution is it's so amazing, but it's also dangerous, and infections, and like there's a lot of stuff that's not something that what is being marketed as you can stream music to your brain. It's like, yes, but your skull is half open, So what is the in between? Where are things still safe, and where is it something that you can put on, but also off sometimes? I think other concepts really go into the body. That should not be experimental, sort of, almost. You can do a lot of experiment, but things can get infected and all of that. But
don't drop your brain on the floor.
Yeah, also not.
We have Yannick here just hashtagging cyberpunk as we go.
But
so actually we crossed our time, so we kept you for more than an hour. I'm very happy with that, though. I want to just ask anybody within the audience here or there, if anybody has any last question or words before we just close. Oh yeah, now we see you.
Sorry, I had my screen the whole time on.
So I mean, that's been awesome. Really, thanks a lot for joining this series, and it's been a pleasure.
Yeah, for sure. Thank you so much for the invites, and I'm gonna keep an eye on your channel and the stuff that you do.
Sure.
I'm always happy when people more fight for this field. So
thank you for inspiring the community.
Yeah, awesome.
Thanks a lot.
Greetings there.
Have a good day.